Welcome back again. This is Fox, another satisfactory video. Today I'm going to be going over my aluminium production, or one section of my aluminium processing. This here, which I've just completed, is turning 4,800 bauxite and 480 oil into 3,200 aluminium casings. I have already done a few of these sections of this aluminium processing a bit further down the line, so I'd already worked out the best way to do it. So for this one I just wanted to cram it all in, get it as most compact as possible, which as you can see I've achieved here. So yeah, I'm just going to run over it with you, show you some numbers, talked about what decisions I made, what alts I'm using, some little tips if you're planning on doing this yourself. So yeah, we will bring in quickly the calculator. I'll split it into, both the sides are identical. Both the sides are making 1,600 aluminium casings a minute. You can see what we needed was, just ignore these. These are items that I had made already for different projects. So we needed 240 crude oil, 2,400 bauxite and 720 water. That's all we needed to make all these aluminium casings. Bauxite, obviously I've pillaged the whole map. I'm using every single node of bauxite there is for this project. What wasn't being used in my battery production and my nuclear setup, everything else that was left is now being used in this thermal propulsion rocket. You can see it's coming in there. It's coming in there. It comes in from all over the map, all to the central bus. Gets fed off to where it's needed. So let's talk about the petroleum coke first. Yeah, so the alts I've used to do this are sloppy alumina solution. This is the easiest one. It just needs bauxite and water to give you alumina solution. I'm then using the alternate electrode aluminium scrap recipe, which uses alumina solution and petroleum coke. Petroleum coke is obviously made from oil, so that's where we'll start. So the oil comes in. This is split into two sections, if you like. So the whole thing's split in two, so it needed two lots of 2,400 bauxite, and then I've split it into two sections again. So 1,200 bauxite, 1,200 bauxite, half the oil, or a quarter of the oil, if you get what I mean. So there's two complete sections here. This is producing the petroleum coke for these refineries. These are producing the alumina solution for these refineries. Same with this setup here. And then it all goes over here to be processed. So petroleum coke is a piece of cake. It comes in. You need this alt, which is alternate heavy oil residue. This turns crude oil into heavy oil residue and polymer resin. Polymer resin just gets belted down underneath, comes back up, and it's just being synced. It was a tiny amount. It's only 80 per little cluster. It was 320 in total. I don't need any more plastic or rubber for the whole project or anything that can be made from polymer resin, so just sinking it, keep it out of the system, keep things flowing. So yeah, you're going to have to excuse the FPS. As you can see, I'm super late game. The FPS is taking a bit of a dump here and there. So yeah, crude oil comes in, turns to heavy oil residue. Then heavy oil residue gets turned straight into petroleum coke. Absolute piece of cake. I've done these refineries back to back, so the heavy oil residue from one comes straight to the other. The numbers are perfect. I needed 4 refineries of each. You can see this is where the polymer resin comes down, goes away and then goes up to the sink. Petroleum coke I've merged all onto one bus. Then it goes off. Split into 2 blocks of 3. This 3 and this 3. Low balance perfectly for this block of 6 refineries that need the petroleum coke. So as I say, these are the scrap refineries. They need 80 petroleum coke per refinery and 240 alumina solution. Now these have been overclocked. You can see I've overclocked these to 133.333%. The reason for that is that it was the ratio for the 1,200 bauxite was 6 refineries doing the sloppy alumina solution and 8 doing the electrode scrap. Now that meant I would have had to bust the alumina solution into one pipe and then branch it all off. I wanted to have the refineries back to back, so the simplest solution is to just overclock each one of these an extra third, so that these 6 refineries are taking up the 2 extra, so 6 to 8. 6 thirds is 2. 133% means you can have them back to back, which means you can transfer the alumina solution straight from the sloppy alumina solution refinery into that electrode scrap refinery. piece of cake. No waste from this setup, apart from the water. This is where it gets interesting. If you use these numbers exactly, it works out perfect. For 3 extractors per 3 refineries. So these need 200 water a minute, yeah? There's 6 of them. That means they need 1200 water a minute to run the sloppy alumina refineries. Now these 6 aluminium scrap refineries produce me 840 water a minute, which means I only needed 360 water fed back in the system to fill this up. Now, luckily, water extractors run at a rate of 120, so 3 water extractors gives me the 360 a minute that I need to fill the system back up. I don't need any valves. I don't need to, as I say, I don't need to set a valve to make sure it's only accepting the 360 a minute. These are producing exactly what we need for the system to run perfectly. As you can see, these water are always full, always at 50. As soon as it needs more, it's pumped straight back in. These ones are always empty. I mean, there's a tiny little bit in there. I'm not going to worry about that. You can see it always goes down. Nothing in this one. Nothing in this one. Now, the way I've done this, to make sure, because of the amount of water you can get in a pipe, obviously, is the maximum is 600. These need 600. These need 200, 200, 200. So I've just split this in half again. You can see the water from the extractors comes up, split dead in half, so it's getting 180 each side. These are valves, so nothing can flow back this way. The water output from the scrap refineries is split in half as well. You can see there's a pipe missing here. So the water that these are producing as a byproduct, these 3, flows round, mixes with 180 coming from the extractors down there, and then that means that these 3 are working perfectly from the water from these 3, plus half of the water from an extractor. Seems a little bit overcomplicated, but it really is the simplest way to do this. Obviously feed the water in both ways with a valve, have the refineries back to back, split them in half, so 3 come this way and 3 come this way. The bauxite, you'll see, is simply load balanced. Again, I've split these in half. They needed 600 for a block of 3, so I've got a 600 line of bauxite coming in, split in 3. 600 line of bauxite coming in, split in 3. 6 times 4 is the 2400. 2400 bauxite that we needed to run this. 2 identical setups, exactly the same setup. This set of 3 water extractors producing the 360 water that we need comes up along here, up into this junction, split in half, pushed either way, and then, as I said before, the water from these 3 scrap refineries comes back to fill these up with half of the water from the extractors. These 3 comes back round, fills these up with half of the water from the extractors. It really is a piece of cake when you do it back to back like this. The numbers work out perfect, as I say, to feed the water back around from half and then just inject the amount that you need for the refineries to fill it up. So once we've got the electrode scrap, now these are producing an awful lot. These are producing 400 electrode scrap a minute. Now, these at default need 60. Now if we do 400 divided by 60, it's a stupid number, 6.666667. So each one of those refineries would have fed 6.6667 of these, what are these called again? Smelters. Now, to save the hassle of that, I wanted to get it to 6. Anytime you can get it to a multiple of 6 is a bonus because it's perfect load balancing, 2 splitters. So, to do that, I needed to overclock all of these to 111.1111. 111.11111%. That means they needed 33.3. That means they needed 66.667, sorry. So, 66.667 times by 6, just over 400. A smidgen over 400, which is what one of these scrap refineries is producing. So, if we've got 6 scrap refineries each one of them can feed 6 of these. That means we needed 6 groups of 6. So there's 12 in this row. So 1, 2, 3, 4, 5, 6 being fed by these 6 scrap refineries. And then 1, 2, 3, 4, 5, 6 groups of 6 again. 36 smelters being fed by the back set of 6 refineries. Each refinery feeds a cluster of 6 smelters. Easy peasy. And there's a bit of spaghetti down here. I mean, it is well organised. You can see. I'll show you how I've done it. So the output for these is here. You can see each scrap refinery comes down into its own merger and is its own lane in this bus. Scrap refinery, its own lane in the bus. So each one of these belts is carrying 400 scrap. Then each one of them shoots off to where it needs to be. Is fed into one splitter, which then feeds 2 blocks of 3, so 6. Each 400 line can feed 6 smelters. Really, really easy, nice and simple maths. I mean, I did need a lot of power shards for this. Obviously, I'm using a creative mode, so I can just spawn in as many as I want. This probably wouldn't be a practical solution if you were playing full vanilla, because you would need 72 power shards just to run this. And also, you need some power shards to do the sloppy alumina solution refineries. See, these using 1 each as well to get these up to the 133.3%. So once the smelters are then done making that aluminium ingots, they then go off to the constructors at the end to make the aluminium casings. Now again, for the sake of numbers, I literally ran out of space here. I really wanted 2 lines of 12 constructors here so that they could all deal with a block of 6 each. But because I ran out of space, all of these grids, all of these platforms are identical in size. They're all 31 tiles by 31 tiles, and for the sake of symmetry, this is all the space I had at the end. So all of these are overclocked massively. They're overclocked to 222.233%, which means I needed 200 aluminium ingots each. Now, each one of these is making 33.33. Divided by 33.33333 is 6.666. So 6 again. So each block of 6 smelters comes from 1 refinery. Each block of 6 smelters feeds 1 constructor, because I've overclocked everything to the numbers that be. That means each constructor is making me 133.34. So 133.34 times 12, 1600 aluminium casings. That's a lot of work this was. It took me a good 8 hours to do this. In all honesty, I made this one. I used area actions, copy and pasted it over here. Bearing in mind, area action doesn't do any of the belt work for you, any of the power supply and any of the power sharding or anything like that. It literally just copied all the buildings over. So it saved me a good hour probably using area actions to copy and paste the buildings over. I then still had to go in under here and create all this marvellous spaghetti and power it all up. What I do with the power to keep it nice and neat is obviously I remove the foundations where the conveyor lifts are going to go down, and I'll stick these just the normal bog standard power line adapters to the side of the foundations, loop the cable up and then get it straight up, loop the cable up, give it straight up, give each one of its own one. That way I've got no visible power poles. I mean, from up here you can't tell where the power lines are. Everything runs around. I mean, there's this one coming across here. I probably could have fed that through the floor underneath and brought it back up. But yeah, it's a cool way of doing it. I mean, it's, as I say, from above you can see no power poles and it all looks nice and super neat. So yeah, the numbers just worked out so well for this. Anytime you can keep anything in a multiple of 6 or 12, it's really, really easy. Especially if you can feed these. The main thing what made this so good was feeding the output of one of these scrap refineries into a cluster of this 6, because it literally was an absolute piece of cake. I just needed one splitter, splitting it into 2 blocks of 3, Everything's running at 100%. This is at 97, that must be why. 99. It's been running for ages now. 99. Suffice to say, they've all got enough. None of them are running out, none of them are stalling. Same with the aluminium ingots. Everything's cool. Nothing's backed up. None of these have got any aluminium ingots in. Everything's working at 100%. For now, I've just been feeding these into these crushers, into the awesome sinks, just to keep things flowing. This is a little balancer just helping me sort things out. These two outside lines were pure nodes, so there was 180 left off each. So 180 and 180 is 360. This then feeds down here. Merges with an impure line coming from the other way. So there's 660 on one line when we only needed 600. This was an impure line. It's getting merged with that 360 from the leftover from the two pure lines to give me 660. Because there is a little bit extra in this line, I'm just doing a basic, when this is full, overflow into this one. Just to keep things going and keep all the lines maxed out. So I had 60 left to play. Out of all the bauxite in the world, I had 60 left to play free. It's mad. So yeah, I'm just feeding it back into here just to keep these next two lines full. It does it again somewhere else further down the line. I believe it's here, yeah. So when that one backs up full, this comes down, feeds into that line. So all of these have got an extra 15 or 20 or so, if you like, pumped into the line just to keep things full. But yeah, that is it. I'm sorry if I talked a bit fast. I really didn't want this video to be super long. I was just really happy how this turned out. Really happy with the way I managed to squeeze it all in. You can see this side. I've put all the walkways in. I literally just left that open for now so I could fly in and out easy just to do this video for you. This is an identical setup to that one that we've just been over. Or has this got no aluminum scrap? I'm guessing the water is filled up for some reason. Let's follow it. Can't get through. So this top line is empty for some reason. Full of water. Strange. Check this quick while we're here. So the water should come out. Feed back in here. This is full. This is full. This is full. We've got two valves here. That's flowing. That's flowing. This valve's on backwards, that's why. Simple mistake. The valve was on the wrong way around, stopping the water from backflowing. That needs to go that way. That one's the right way. That should sort that out now. Yeah, it's flowing now. I need to just clear these a couple of times until it gets out any excess water. I'll tell you what, I'll just flush this part of the pipe section. Trace the water back from this, make sure that the extractors are not producing more than what they needed. Shouldn't be, I definitely didn't put any shards in. There's no valves here either. Pump's working fine. That's full. Three 120s is 360, which is what we needed, so that should have sorted it out. I'll take it was just that valve. Seems to have cleared it. There's always something with these setups. I'm just going to check this one over here. Make sure all these scrap refineries are not filling up with water. That one's empty, 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 empty. Yeah, perfect. So one wrong valve can cause you an awful lot of hassle. Yay. Anyway, I'm digressing as usual. I hope you enjoyed this. I really enjoyed making this actually. Just the fact of trying to squeeze it all in here. The only amount of space you need when working with refineries and constructors is 2 wall space down. So I've got 8 meters of height here. You can see I've got 2 wall spaces between the top of the 2 meter platform and the bottom of this, so it's only like 6 meters I'm playing with really, because there's 2 meter platforms here, but everything's working fine. This was the one that was stalling. You can see the the scrap is coming in fine now. Yeah, looks cool. Let's fix this back and then I'll call it a day. So yeah, for the next one I've got a few more tips. One is to deal with large quantities of screws. How to deal with large quantities of screws in Satisfactory. Everybody wants to know how to do that. I've got a cool tip for that. It makes the whole thing super easy. Don't have to worry about transporting massive amount of screws all the way across your factory ever again. But yeah, for now, if you've enjoyed this, please give it a thumbs up. As always, please subscribe if you haven't already. Link in the description to the Discord. Come join the community, share your projects with us, and yeah, stay tuned, and we'll see you in the next one. Cheers.